Let me draw that rod. No, there's a rod, no. No, can you remember the formula? I think can you remember the effort we have put it? Why it is not coming? Yeah. Now, there's a infinite long rod here. I want to find out the field using Gauss law. So I suggest here you assume a Gaussian cylinder. There's a Gaussian cylinder I'm asking you to assume. So what is the radius of Gaussian cylinder? Let it be R. Length of Gaussian cylinder, let it be L. Then we know how E bar, I'm asking you to assume a surface like this. Let this be E bar. And this is N cap. And this is DS. Okay, I agree this one. What about here, sir? Here also there. But how N cap here will be for this surface? And what about here? N cap will be in this direction. Cylinder, I think you know, there are three faces will come, no? Two flat and this is a curved one. Agree this one. So everywhere what happen? The E bar at additions are will be constant. Can you remember the formula? Already we derived, we know it. E bar at all points is a constant. And we have even defined this as a lambda, mass per unit length. Okay, let's come for the formula. I assumed a cylindrical Gaussian surface. What is this? This is a cylindrical What about E bar dot ds for this surface will be 0 because here E bar will be tangential to surface. E bar will be tangential and n cap here. So the E bar dot ds will be 0 for this surface, will be 0 for this one. Only for curved surface it will be non-zero. So now I think I'll give name surface 1, 2, 3. Now what is the value of? Let me proceed here. E bar dot ds for surface 2 and 3 will agree this only due to 1 it is non-zero, so therefore the total formula is equal to 4 pi g. What is the net mass enclosed? What is the mass enclosed? Lambda into L, because lambda is mass per unit length. Net mass enclosed will be lambda into L. Let's calculate this one. E is constant at all points on cylindrical surface, but sir, what about due to 2 and 3? It is 0 anyway. No. So the finally the formula what happened? It will come out like this. Now, what is the surface area of a cylinder? Curved surface area. I think this is the 1L, right? Due to surface 1, we are finding. What is the curved surface area? 2 pi RL. Now look at the formula. G lambda L get cancels. So 2G lambda R. Check the answer. Is this what we derived for long rod? Anybody, if you're having a doubt, go back and check the answer. Yes, in fact, this is what the field due to long rod, no? How many steps? Within 2-3 steps, no? To get the same answer, I think we struggled a lot. First, due to finite rod, we should be very good integration. We should take care about the limits. Then there, put alpha, beta, 90 degree. Then you'll end up with answer. Look at this very beautifully. Within 2-3 steps, we got the answer. It's a law. You can't do anything. It's a law. So don't try to change, sir, why only like this? It's a law, finish over. You should know how to utilize it here. What is value of E bar dot ds for surface 2 and 3? Because the E bar is, I'll show, because how E bar will be directed like this. Am I right? So what is the angle between E bar and N cap at surface 3? Will be 90 degree. So why it has become 0? Because E bar is perpendicular to ds at surface 2 and 3. That's why what happened, it is 0, that one. So shall we slowly take help of this one only? I think you see that one more. Due to large sheet, we derived expression, no, morning. Due to large sheet, we have derived expression. This one. Anybody, can you give the answer? How much it was?